Hello, tigers. Don't you feel like a tiger with this black and gold? It's kind of cool looking. I know your slide is kind of dark, and so as you're taking notes, if you would like to just do that on another piece of paper, you can, or in the margins. All you're going to be doing, as you know, is to write. You're just going to be factoring. So it's just going to be by a couple of binomials, unless you have to factor something else out first, which is going to happen to you today. I can identify and factor perfect square trinomials. So this is factoring special cases. You're going back the other way from a direction that you've gone before, which was when you were using the FOIL method and we talked about special cases. It's not a huge lesson, but it's actually kind of a way for you to do this a little easier. And so I'll just kind of be pointing out your thought process as you work through. Vocabulary. Perfect square trinomial is factors into identical binomials. Identical binomials. Oh, I kind of like that part. Factors from a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And I just always like to put that reminder of FOIL is that once you get your answer, if you're not sure if you did it right or not, then you can always go back and FOIL to make sure that you have the right answer. Steps to factor trinomials in the form ax squared plus bx plus c. This is exactly the same thing that was on your section 9.6. So I'm not going to go through each of those, but I would really want to emphasize this number one. It says consider if each term shares a common factor, divide each term by the greatest common factor. And so that's going to be very important as you're doing this today, because if you can factor out a number, it's going to make it easier to do your binomials. Please consider that. And it's necessary because it's not really factored out until you've done that step. So I know that it's redundant when you keep asking yourself the same question and the answer is no, but sometimes it might be yes. So looking at number one, I've got x squared plus 8x plus 16. And so I want to ask myself, is there a number that I can pull out of 1, 8, and 16? And we'd say, no, Miss McDaniel, there is not a number I can pull out of 1 and 16. So let's look at what we can pull out of 1 and 16. 1, 8, and 16. Well, we can't pull out a factor, but we're just going to go ahead and make those into two binomials. What makes this a special case is that 16 is a perfect square. And at the same time, 16 is a perfect square. We love that part, which means that we multiply 4 times 4 with each other. We notice that easily I can get the middle term. We love this. It's just we know it's going to be x plus 4 and x plus 4. A reminder that when your C term is positive and your B term is positive, then you're definitely going to have two positive answers. And if I was simplifying this, I would just write it as k plus 4 raised to the second power. I'm sorry, not k, x plus 4, x plus 4 raised to the second power. So that is the best answer. Looking at number two, our C term is a perfect square. We love that part because we know that if it's a perfect square, then the middle term is going to be an 8 and an 8, if that jives with our B term. And so 8 times 8 is 64, and then we've got our middle term of a negative 16. So in order to get there, we already asked ourselves if we could pull out a factor, and wholeheartedly we said no, we cannot. In order to get to 64, I know that it has to be a negative 8 times a negative 8 or a positive 8 times a positive 8, but we notice that our B term is a negative 16, so you may have guessed it. The only way you're going to get there is it's going to be negative on both counts. Also, remember that part of your directions said that it's going to be the same binomial. So n minus 8 squared is our final answer. Now, we see that we know that these are special cases and that's the direction we're headed, but hopefully that if you just had a bunch of different problems, you would kind of start to think, okay, it's a perfect square. What's going on with the middle term? Is it a special case? And you could get there a lot faster. Faster than if you just have to list all the factors and figure it out independently. Okay, so let's look at number 3. And you're going to say to yourself, okay, I've got a 4, I've got a 36, and I have an 81. Is there a factor that I can pull out of 4, 36, and 81? There is not. 4 only has three factors, right? 1, 2, and 4. And 4 isn't going to come out of 81. So we did our job. We asked the question, but the answer was no. And so instead, I'm going to have binomials. And it is a 4t squared, and it's an 81. And so all of these numbers have something in common. What is that they have in common? They have in common that they are perfect squares. But the boss still is our C. Our B is our determiner, but our C is really going to decide how we get there. So I noticed that 4t, that's going to be a perfect square, and so that's going to be 2t and 2t because we know that 2 squared is 4. And then 81, well, to get 81, the way to get there would be 9 times 9. So as we're thinking of that, we're also thinking of the middle term. So we know this is positive. So if this is positive, our C term is positive, and our B term is positive, we know that both of these have to be positive. And then if you're just not quite sure, remember our friend FOIL. First makes it 4t squared because it'd be 2t times 2t. Then I've got 2t times 9, 2t times 9. That's going to be outer. That's going to give me an 18t. Looks like we're headed in the right direction, doesn't it? And then our inner is plus 18t. And then our last is plus 81. And I know that when I put these two terms together, then I end up with 36t. We are golden, my friends. So our final answer, 2t plus 9 times 2t plus 9. So what your takeaway here is that your A term is a perfect square and that your C term is a perfect square, and together they are going to create your B term. Let's look at number 4. Oh, number 4 is interesting. You may remember this from your special cases when you were multiplying binomials, and we noticed right away we have a missing term. Did I just write the problem wrong? No, I didn't write the problem wrong. It's because it actually isn't there. It canceled out. Well, how can it cancel out? It can't be exactly the same binomial if it cancels out, can it? But it's got to be very close to each other. I bet you guys already know the answer. So I know I can't pull anything out because I got a 1 and a negative 100. Well, I can't get anywhere there. So I'm going to go ahead and write in my m's, and I know 100 is a perfect square using the number 10. Well, to get rid of our B term, you may have guessed it, one has to be positive and 1 has to be negative, because in the FOIL we would have m times negative 10 and we would have positive 10 times n, and you know that that's just going to cancel. Pretty nifty, huh? All right, we still have 2 more examples. We can do this. Number 5. So I noticed right away that I only have 2 terms. So if I've got an AX term and I've got a C term, you probably are already on to me that something's going to cancel. And so in order to get there, I'm thinking perfect squares. I know 64 is a perfect square. I know 25 is a perfect square. So let's break that into 2 binomials. Sound good? And the square root of 25 would be 5x times 5x. How do I know that? Because my middle term is missing. So they have to be very, very similar, meaning the same. 64 is 8 and 8. But then because it canceled, 1 has to be positive and 1 will have to be negative. Let's look at number 6. Is there a number that you can pull out of 28 and 7? And the whole class said yes. Finally, it's paid off. We've asked ourselves this question how many times, and the answer's been no. And now all of a sudden, right now, it is yes. And so I'm going to pull out a 7. Let's pull out a 7. And when I do that, to get to 28k squared, I'm going to multiply 4k squared. And to get to negative 7, I'm going to multiply by negative 1. So that's just kind of backwards distribution. I pulled out a factor of 28 and 7, which was 7. And then 7 times 4 is 28, k squared. And then 7 times what is negative 7? That's a negative 1. As far as the 7, it's just going to kind of hang out. You just keep bringing it down. And then you're going to break this into two parts. And please understand, this isn't just a formality. It's not a, oh, well, she pulled out a factor, I'll just figure it out my own way. No, 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 no. If you don't factor it fully, then your answer will be wrong. And so make sure that you force yourself into asking that annoying question each time of, can I pull a factor out? Because it's not factored if you don't. Then from here, okay, I've got a missing term in the middle, so I know that one is going to be positive, one's going to be negative. 4, well, the square root of 4 is 2, so that's going to be 2k. Didn't give myself very much room to write there. And then 1, of course, is going to be 1 and negative 1. And that is our final answer. I hope that you really enjoyed your lesson today on factoring special cases.